So the first one being the bovine identity, which is the cattle identity, just like Aadhaar. Of course, I'll walk you through as we sort of go forward. And the health index, which is based on the images predicting the health of the cattle, and based on the images, the udder images, side images, predicting the milk yield of the cattle, and using all this data coming out with a report card, right? So where and how this is useful in lending and insurance, the dairy lending, what happens is only the farmer or the household is underwritten, right? So a cattle loan is given like a personal loan. So the farmer KYC will be done, farmer's credit score will be checked, right? And some photos of the cattle will be taken, that's all, right? So there is no understanding of the cattle, there is no understanding of what is the income from the cattle and all that, right? So now what the tools that we have essentially built helps in understanding the cattle using the images, and based on that create a scorecard. So what we have essentially built as part of the stack is we have built a cattle KYC and cattle scorecarding, right? So now if the farmer has got, let's say, 4 cattle, all the cattle will do the KYC and the scorecarding, and the herd scorecard will essentially come. This, along with the farmer's credit score, will help in better underwriting. Let me take some of the challenges in the lending and insurance. One of the classic things is the same set of cattle, multiple farmers will use for getting the loan, right? So, some of the cattle, we don't know the health. And especially when it comes to insurance, there is no understanding of the health of the cattle before giving the insurance, or during the death of the cattle. Probably the cattle could be swapped. You never know. Imagine how hard it is to identify a buffalo, right? So right now as we speak, the cattle is identified using the ear tag. That is a sort of a fundamental problem, right? So let's say if both of you have ID cards, you just swap. Will I know who's who? When I ask you looking at your ID tag, I'll be reading her name, correct? So ear tags are like that. So it's a physical card which can be easily tampered, it can fall down and sort of all that. And there is enough data where roughly about 10 to 12% of the tags are either fall off or it is swapped and things like that, right? And it creates a whole bunch of problems. So what we have done is we have essentially created a biometric driven unique identity for the cattle, right? Anyone here without Aadhaar card? I would be very surprised if anyone is there, right? So all of us are identified using our fingerprint, right? Which is our biometric. Now, interestingly, the nature has a unique identity for each of, almost all natural beings, especially from an animal world. Especially with respect to cattle, between the nostrils, you see the patterns, right? So these are unique to each cattle. There have been multiple papers published since 1950s. People have taken. So what we have done is we have used the digital medium, which is our mobile phone, created an AI-driven app, which can essentially understand that this is a muzzle, right? And the patterns are more recognizable, and it can essentially differentiate a non-muzzle. So you point the camera, the box will not come. If the muzzle is there, but there is some mucus or dirt, a red box will come. Once you clean it, it will become a green box. It will automatically capture and sort of all that. So here is a small sample video. So what we have done is, given that this biometric identity is there, we have used the mobile to create a solution where it will automatically capture the images along with the patterns, completely user-friendly, right? And it will store these images, create an ID for the cattle, and now this becomes Aadhaar equivalent for cattle, right? So the same cattle cannot be used for another loan, right? Or during the insurance, when this is onboarded, right? During the death of the cattle, the muzzle can be captured and the insurance payout can happen, right? So the falling of tags and all that will not be a problem. And sometimes, the cattle is also swapped, right? which becomes a loss for the insurance companies, right? And enough times this entire operations is a lot of cost, right? Because somebody has to come, verify whether there is a ear tag, take photos and all that, right? Now with the muzzle, the farmer himself or herself, she can even validate the cattle, right? All that can essentially happen. The same thing from a insurance onboarding, not just from a validation standpoint, right? Right now as we speak, if the farmers want insurance, somebody has to come to their location, right? And that adds a lot of operational cost to the insurance, right? So now with this unique ID, the insurance companies will be sure which cattle is insured, right? So it doesn't matter whether a field person does it or the farmer himself does it, right? So the muzzle identity significantly helps. Similarly, in terms of the lending, whenever a cattle is being onboarded, the system will be able to check whether this cattle has been already used for any loans. If that is so, it will not be added. So, though these patterns are there, cattle, of course, I'll just briefly dip down. For example, this is a pigmented muzzle, right? So, the amount of pigmentation changes over a period of time, right? So, we have essentially tested for all that. Then the lighting might be slightly different, right? The orientation might be different. And calves, right? So we have tested from calves to, the same calf, we have tested every 2-3 months, right? So, and checking whether the patterns don't change and whether our algorithm is able to detect it correctly. So both are true, right? So, and even the, sometimes the color of the muzzle also changes, right? It can become from light to dark. Or dark to light. So here is a sample of the actual insurance, right? Where, can you see any difference between the top and bottom buffaloes? It looks almost the same, right? Now if the ear tag is there, the insurance payout would have happened, right? But using muzzle, we were able to identify that these were 2 different cattle. So this is another sample. Right? So muzzle essentially gives a unique identity to the cattle, and this will really help in cattle becoming an asset class, right? So right now as we speak, the farmers having land in rural, land is considered as an asset, right? But unfortunately, cattle is not considered as an asset, though it gives milk and there is revenue and there is a recurrent revenue more frequently than a land, right? But because there is no unique identity that is tamper-proof, cattle is not considered as an asset and the farmers cannot leverage it. Now with the unique identity using muzzle and the technology to sort of identify the cattle can essentially become an asset class and the financial inclusion can happen via this asset class, right? And we have done multiple pilots with both the central as well as the state governments, and at some point in time, we really hope that the Aadhaar is linked to this muzzle ID, right? So you will know based on Aadhaar, right? Just like how many land holdings are there, assets are there. We can essentially say that at this given point in time, as per the registration, how many cattle is there, right? So this has good potential to even become as part of the DPI, digital public infrastructure, right? Where we can sort of know at a macro level the asset availability at the farmer, which will help in better underwriting and financial inclusion for the farmer. Any startup, the why, what and how is sort of extremely important, right? Why that particular problem is important to solve and what sort of value proposition it essentially provides. So AI essentially comes in the how part, right? Can you solve it with AI, right? And sometimes it is very important that, we need to understand, can AI solve it, right? Not all problems, just like in life, can be solved by AI, right? Sometimes the solution for some of the problems is just enduring it, right? So AI cannot solve all problems. So you have to essentially first understand whether AI is going to be useful or not, right? Then when it comes to the value proposition, whether it is sort of relevant to the industry and the market that you're sort of working on, and you need to be also able to quantify the value, right? Because AI also essentially comes with a cost. And when you are essentially developing the problem, you need to also think about what is the unique differentiation that you have. Let's say if you're going to use just off the shelf ML algorithm, right? What sort of a differentiation you're going to bring to the table, right? Is there some domain specific additional data points that you have in terms of building those models? Or is there variations in the models that you've sort of brought in, and what level of accuracy is that it is sort of bringing in, right? I just gave the example from a muzzle standpoint, right? So, and competition, right? Sometimes, so what is it going to take for the competition to build an equivalent, right? So that is also something that you need to think through before essentially jumping in. Hey, here is a problem that AI can solve. Now let me make that as a startup. Is not the right approach, right? So, and of course, at the end of the day, any business needs to make money, right? So you need to have strong business alignments while choosing and working on those problems. So the other key thing, especially sometimes the first portion works, but the second portion doesn't, right? So you should be able to sort of clearly break down what is the cost of development, what is the cost of distribution, right? And whether the unit economics works, whether the revenue on a per usage or per delivery, does it substantiate, whether the unit economics sort of work, right? Of course, some of the engineers, I'm sure, sort of want to move more towards AI, right? Why? Because there is more need for it and there is more salary for it, which also means there is more cost for the company, right? So AI engineers don't come cheap, right? So you need to also ensure that the cost of development substantiates the revenue, right? So this is also very important consideration when you think about building AI-driven solution. One of the other key things that I've essentially seen is in terms of taking the problem as a whole, right? Sometimes most of the AI engineers, they just look at the problem and then keep literally showing the data and asking, hey, why is the algorithm not giving me the results that I expect, right? So how do you define the problem is a significant factor in terms of why or why not your algorithms are working, right? Especially all those models, whether it is converging properly or not, right? So defining a problem is very key. So that's where breaking down the problem is extremely sort of important, right? Let's say in the case of the health of the cattle, right? You would see the red, amber, green, but internally there are multiple layers, right? If I just keep giving the data and ask for the result, the algorithms may not sort of converge to a model with a reasonably high accuracy, right? So at the end of the day, the accuracy and the convergence is extremely critical, for which how do you break down the problem, how do you define the problem, and what do you expect from the algorithm, right, is a key factor, right? So you need to essentially build, sort of break down the problem into subsets and keep solving for the subsets, and then sort of bridge the whole, and then eventually it will sort of, as a overall block, it will solve the problem that you are overall trying to work. The other thing essentially is in terms of working end to end, right? One of the other key things that I see startups and especially the ML engineers sort of work is, hey, I'm this data scientist. I'll not work on data pipelining, or I'll not work on the data collection, right? So that is ideally not a good approach, especially if you want to solve a problem and take it to the market, right? Enough people who develop the solution should be involved end to end, right? You would have seen, for example, when it comes to the muzzle match, we didn't work only on the algorithm that matches the muzzle, correct? It starts from the collection of the data, right? All of us know garbage in, garbage out when it comes to the algorithm, right? If all my friends jump from the 10th floor, the algorithm will tell me to jump. Whether I'll do it or not is different, but the algorithm will tell me to do, right? So it is very important for the team and especially the ML team members to be involved from the data collection to the production, right? So that gives a sense of, ensuring that the data that is collected is in line with what you expect the data to be. When you build the algorithm, you are sure about the data that is coming in will support the kind of settings that you have as part of the algorithm, right? I've seen way too many companies where, for example, some variables or some images are expected to be in a certain format, but it would be a null or it would be a variation, right? So the team that is getting the data doesn't know that they have to essentially give it in this particular format or there are some errors here. But the ML team will think that it is coming in this format. But the accuracy will be like somewhere around 75, 76% and it will not go above that, right? So it is sort of very important that you work end to end. So the other most important thing is you will never hit 100%, right? So sometimes, so this especially happens when you go for the testing and even in production, right? The business team will come and ask, hey, we have built this, but here is where it is not working, right? So no algorithm will ever be 100%, right? So just like humans, so to say, right? So the right way to sort of test the algorithm is with a sufficient large number of test sets, right? So let's say, when we talk about accuracy of 99% plus, it essentially means you need to have tested at least with 100, right? Only then that accuracy is there. If I test with probably 5 and all the 5 comes as correct, I can claim 100%. Even if one goes wrong, my accuracy is 80%, right? So you need to test with a sufficiently large data, and sometimes it is okay while building the algorithm to say that, hey, I'm fine dropping this 0.5% accuracy if the data comes this way, right? Because in the marketplace, the odds of that kind of data coming in might be very less, right? I'll just give you an example. So the relative accuracies for the muzzle of a grown cattle and a calf is different, because for a calf, the size of the patterns is limited, right? So it is more stretching for the algorithm. But how many number of calves will be insured? Not as many comparing to the cattle, right? So I would rather put all my effort into a 3-year plus cattle than a calf. See, of course, in our case, we were able to sort of reasonably get a fairly high accuracy. I'm just trying to give an example. So defining the problem, breaking it down, and sometimes foregoing some level of accuracy, right, even at the start, will help in better convergence of the solution. Thank you.